Hello everyone, today I'm going to be talking about the volume between two curves. So this question is asking us to find the volume of the solid obtained by rotating the region bounded by y equals x cubed and y equals x around the line y equals minus 4. And they told us that we're only finding it from x equals 0 to x equals 1. So that's our domain. So if we draw a line here, this is the only region that we're gonna focus at. So we can already see that the curves, they both intersect at 0. So this is our curve y equals, and let me make that a bit neater, y equals x cubed and y equals x. And then they said from x equals 0 to x equals 1. So this is 1. And the reason that this is 1 is because if you were to find the point of intersection between the curves, it would be 1. So here to show it, I would set x cubed equal to x. I'll move the x to the other side, so x cubed minus x equals 0. Factor out an x, you get x squared minus 1 equals 0, and then x equals 0, and then x squared minus 1 equals 0, and then you get x equal plus minus 1. So right here, the reason that we're gonna cancel out the minus 1 is because it's not in our domain. So again, we said that we're only gonna focus on the region from 0 to 1. So anything in this region does not count. So we got a bit lucky since the point that they told us about, which is x equal 1, is actually where they intersect. So in other questions, this might not be the case, and in that case, you would need to do more than one integral. So now that we have our graph sketched and we know the point of intersection, now we can just use this formula right here. So recall that the volume is the integral from pi r squared minus pi r squared. And then don't forget the dx right here. So what exactly is r? So r is the distance between the line of rotation to the curve. So in our case, this would be capital R, this distance right here, and a lowercase r is this distance right here. So the reason that the distance between y equals x to y equals minus 4 is the capital R is because it's a longer distance than the distance from y equals x cubed to y equals minus 4. So we need to find r. So the way to find r is basically, the easiest way to think of it is just the distance between y equals x and y equals minus 4. So we know that the distance from y equals x to the x-axis right here is simply just x. And we know that the distance from the x-axis to y equals minus 4 is 4. So if you want to find this whole distance, then it will be just x plus 4. And now we need to do the same thing for the curve y equals x cubed. So now we need to find this r right here. So again, the distance from here to here, so from y equals x cubed to the x-axis is x cubed. And then the distance from the x-axis to y equals minus 4 is 4. So combine these together, you get x cubed plus 4. And again, this is the distance from here to the line of rotation. So now once you have figured out what the r values are, now the problem just becomes very trivial. So all now you need to do is substitute your r values into our original equation. So now we get volume. So now we get volume. Okay, let me use a better color. So volume equals, you can factor out a pi, and then you're gonna substitute in the r, both r's. So you get x plus 4 squared minus x cubed plus 4. No, that's not an absolute. So x cubed plus 4. squared dx. And then from there, you just want to expand it out and then integrate. So this is very simple integration. So all you're doing is using the polynomial integration technique. So you're gonna, before solving these problems, you need to know how to integrate. But for the sake of this video, I'm just gonna put in the answer right away. But before we do that, we know that we're gonna integrate from 0 to 1, since that's our boundaries. So where I got that from is, here's 0, this is where they intersect, and here's where they intersect. So from here to here, I'm saying the integral is from 0 to 1. So the final answer you get after doing this would be 46 over 21 pi units cubed. Thank you all for watching, and I hope you learned something from this video.